Hello, I am back to Laplace Transform lecture. Now I am going to discuss Laplace Transform of trigonometric functions. Here I have taken sin 80 as the trigonometric function. So Laplace Transform of sin 80 is 0 to infinity e power minus st sin 80 dt. This integration can be solved by the standard integral formula, that is e power ax sin bx dx is e power ax divided by a square plus b square a sin bx minus b cos bx. Now if we compare with a and b as minus s and a, then we will have e power minus s t divided by s square plus a square minus s sin a t minus a cos a t. Okay. Now look here, there the limits 0 to infinity. So if we take the limits as 0 to infinity, then we will have here infinity e power minus infinity. So there is 1 by e power infinity, and here it is sin infinity and cos infinity. So sin infinity by e power infinity, one type of indeterminate form. So to avoid that, let us change the integration style in this way. Limit x tends to infinity, okay, and 0 to x. We have changed this limit in this form, that limit x tends to infinity 0 to x e power minus st sin 80 dt. Okay, look here, here we have taken a finite number x, and this x tends to infinity. So when x tends to infinity, it will become infinity, and this integration will become as it is. Okay, now if we do this integration, we will have this part, and the limits are 0 to x. Now let us put the limits. Limit x tends to infinity, and here let us put x. Then we will have e power minus sx divided by a square plus a square, and minus s sin ax minus a cos ax. Okay, and then we will put this 0. Okay, if we put 0, then e power 0 is 1, and divided by a square plus a square. So we will have minus 1 by a square plus a square, and here you see, if you put 0 here, then this term is 0, and here minus a cos 0, that is 1 minus a. So we will have minus a. Okay. Now you look that if we take this infinity in this case, then e power minus infinity, and here sin infinity and cos infinity. So as it is e power minus infinity, so we will have 1 by e power infinity and 1 by e power cos infinity. So we have to find that. Let us try to understand by the sine and cos graph. Let us draw the sine curve or sine graph. Sin x passing through 0, 0 and range of sin x graph is plus 1 to minus 1. So range is minus 1 to 1. Similar for cos x graph. Cos x also bounded in between minus 1 to 1. Both the functions cos x and sin x are bounded in between minus 1 to 1. So whatever value you take for x, if x tends to plus infinity, whatever value you take, sin x or cos x always remains in between minus 1 to 1 because they are bounded. Therefore, some finite value divided by e power infinity, some finite value divided by infinity, some finite value divided by infinity, obviously 0. So we'll have 0 and this minus and that minus will be plus, and here we'll have a by a square plus a square. Okay, so Laplace transform of sin 80 is a by a square plus a square. Similarly, you can find Laplace transform of cos 80 also using the standard integral formula. Let us see all the Laplace transform of different type of functions we have found during these two lecture classes. So Laplace transform of 1 we have found as 1 by s. Laplace transform of t as 1 by s square. Laplace transform of e power at as 1 by s minus a. Laplace transform of sin 80 as a by a square plus a square. Laplace transform of cos 80 you can find that will be s by s square plus a square. Now look in the right hand side, all of them are functions of s. So we can write fs. This one also fs. Similarly, these are also fs. Fs is Laplace transform of function ft. So what does Laplace transform do? Look here. Ft means the function of real variable. T is real variable and t is always greater or equals to 0. And this s is a complex number. This is a complex number and it can be written as alpha plus I beta form. So what does Laplace transform do? Laplace transform converts the function of real variables to the function of complex variables. Laplace transform is very useful in different engineering branches, computer applications, social sciences.
For admission and course-related enquiry, please visit college website http://www.svist.org/.
In the next lecture, I will discuss more shifting properties, Laplace transform of derivatives, and the solution of simultaneous differential equation using Laplace transform.